All right, guys, we'll begin. Hello, everybody. My name is Jeffery Sologov. I am a solutions architect at ADP. We are known for doing a lot of payroll. We also have another division that does a lot of automotive applications. I'm here to talk about the pitfalls of building large-scale apps. I needed a dramatic title, so that's my way to make it dramatic. So this talk is going to be in 3 parts. I don't have a demo per se, so if you're into demos and code, this is not that. But I hope that it gives you a little bit of an insight into kind of at least my perspective of what it takes to build a large-scale app. Everybody has different perspectives. I have a few friends all over different companies, and Twitter has its own perspective. Netflix got its own way, eBay, and many startups. So this is basically my culmination of different things that I've learned over the time that I hope that it helps you along the way as well. So the 3 parts are, the first part is very simple. It's just I want to make sure I kind of give you the basics of the things that I believe in. Those are the fallacies of distributed computing. That's kind of my Bible. That's what I go by. Every time I have a discussion with anybody, that's what I fall back to. If I don't have an answer for something, that's kind of what I fall back to. The second part is more about just as the application kind of grows, what coupling really means. We have different perspectives of what coupling means, and I kind of want to put a little bit more of a scientific aspect on what coupling really means to people. And the third is really, all right, so I got a background, all right, you told me about the coupling. All right, how do I put an application together? What are the different ways? What's your way? So I'm going to talk about the things that I believe in and some of the technologies behind the scenes, including Spring as well. And hopefully it'll make sense at the end. If not, during the conversation, please ask me any question you like. So let's begin with the fallacies. So fallacies, right? So like, what's a fallacy? Well, a fallacy usually is, so somebody said, no, I've been doing this for so many years, so many developers believe in this, but through experience, it's actually a fallacy. So you should really think about things ahead of time. The reason, it's like a pattern, right? You've got all these different patterns, the gang of 4 and so forth. The reason it's called a pattern is because over time, right, people kind of figured out that for this particular in this particular context, for this particular problem, it makes sense to apply this pattern. Fallacy is kind of like 180. Over time, you think it's one way, but you really should think about these type of things and the type of things I'm going to talk about. So the first one is probably the most important, and that's kind of the idea of that the network is reliable. I actually, no joke, got a text message from our data center today that a few things went down today. I'm like, oh, that's fantastic. That's great for my talk. Right? Our data center is down. That's awesome. Like that fits in. That fits into my talk. I'm going to apply that. Awesome. Just don't interrupt me for an hour and a half. Go with somebody else. But so everybody's kind of every developer is. We don't really think about that stuff. You just kind of you code, but network is reliable. That's somebody else's problem. And like, why do I care about that? That's network people. That's somebody else. That's not really my my domain. So if I ask you, point blank, do you think the network is reliable? You're probably going to say no. The network is, yeah, the network is completely reliable. No, most of us will say no, yeah. We're on Twitter, we've seen some, we're with Google, we get the news, we see Amazon going down, we see Vine and all these applications going down. So yeah, it's kind of, we know the network is unreliable, but any of us really get into it? Any of us really think about when you code, right? From a coding perspective, do you actually keep that in mind? Do you actually code around it? Like, you know, in this particular step, when things go down, oh, I should care about the data. What do I do? What kind of principles do I apply? What design pattern? What should I do? Do I talk to my business? And so on. You know, do things really, you know, do things really fail? Well, yeah, things really fail. Just to give you a couple, I'm not going to go into like 100 million facts of when the network failed. This is just the Microsoft's data center, internal data center. They've got 5.2 devices per day, 40.8 links per day failing. That's 59,000 packets lost a day. Like, all right, fantastic. Yeah, we'll put a, you know, a lot of times you talk to the enterprise architects and yeah, we'll do a redundant, we'll put a network redundancy. So don't worry about if that one goes down, we'll just do a redundancy and all of a sudden it'll just be magic. So Microsoft did that themselves, right, internally, and redundancy actually helps only with 43%. So it helps, it's great, but 43%. It's not guaranteed to be, if something fails here, we'll just do make the network redundant, all of a sudden everything's 100%. HP has internal support ticket system, right? Every time something goes down, do a little ticket, and basically 11.4% of all the tickets has to do with something being down. That's 2 hours and 45 minutes of downtime. So this is the highest support ticket. The kind of the medium level support tickets are close to like 4.5 hours before they actually fix the issue. Google had a team that did a distributed lock manager called Chubby. And this is Google, right? So if Google can't do it, God help us all. So they had, you know, all right, we've got a team, fantastic. We've got fantastic engineers, best of the best. You build a lock manager and called Chubby, and so in 700 days they had 61 outages. It's kind of important, right? So if Google has 61 outages, I just check out within your company what it's like. And a lot of times you might not get those statistics, but like I said today, at least with ADP, which is a pretty large company, outages happen. This is actually a fantastic link. So I'm not going to go into like every single facts because I could go for 3 hours just of when things failed over the last 2 years. But this is Kyle is a fantastic guy that does a lot of distributed systems, and he put out a list of from routers to switches to Amazon to firewalls being down, and very specific use cases of when things are down. So it's not that you know, if I ask you, you know, at the conscious level, do you believe that network is reliable? Yeah, everybody's like, yeah, it's unreliable. But it's, you know, when you code on your laptop. You're in Cube or some fantastic office with a beautiful view, and you code, right? You debug, and it's like, it's fantastic. It works. You do some performance testing, you do unit testing. Yeah, it's all good. Close the laptop, deploy, pop it, whatever we got to do, deploy, we're all good. But in this current world, nowadays, that's not the case, right? You don't just work on one PC. In production, QA, all these different environments, it's not a single laptop. Can't just, right, just because it works on your laptop, not gonna work anywhere else. It's gonna happen. So it's a matter of us kind of thinking of, right, so when things go down, what do I do? What principles do I apply? So it's not that we don't think twice about it. Sometimes we don't even think once. Laptop, right? Debug, done, works, check in, good to go, next. So you have a lot of services. People love web services, so REST services. You've got a bunch of things communicating to each other. So what happens when you get a timeout exception? So you've got one thing talking to somebody else is talking to somebody else, whether it's a web service, a REST, anything you like, anything HTTP. You get a timeout exception. What do? Do you log? Like, what do? Do you notify the client? Do you use a messaging system? Does anybody think about that? Sometimes you just develop and in design session, I'm just gonna service calls another service and who knows, whatever, that's somebody else's team. I'm just gonna call a bunch of services. And so when you get a timeout exception somewhere in the middle, that kind of puts the system in a non-deterministic state. And what do? Does anybody do retries? You do retry? Okay. Depends. On? Okay. So you got like call, catch exception, if this, then do something else. Okay. Anybody else? So, some people do retries. But what happens if it's like service calling another service, calling another service, calling two other services, and it's somewhere in the middle? Is that a transaction? Is that one big kind of was it like, 5, 7 years ago, I forget how many years ago, the WS, the whole standard atomic transaction? Do people do like a whole atomic transaction for all these services? No. Nowadays it's all REST. So the question is, what do you do when something fails in the middle? Difficult. And when you retry, what happens on the other side? You get duplicates. So what do you do with duplicates? Do you duplicate detection? Because that's easy to build. I love building that. Just sign me up. I love building duplicate detection. I have no idea how to do it. Sure, put it in SQL Fire and put optimistic concurrency, and when some ID comes in and you get an exception thrown that ID exists, but you've got services calling services. It's very difficult, and we're kind of in this. Every time sometimes I talk to the team and we're like, we're almost there, almost done. A couple of days, we'll get it figured out. We'll get it figured out. We've got this. We were using whatever data storage you wanna use. We got it down. This service calls something else. We'll store this ID over here, and it'll be okay, right? And then the manager comes in the next week and it's like, "Are you done?" Yeah. You remember how I said 90%? We're 95% this week. We're 95% this week, but it's not really the case, right? It's not. You don't go up the percentage. Sometimes it's. You find new things, you scratch your head, you go, man, that's difficult stuff. I told you 90% last week, but actually this week it's more like 70%. But you can't tell your manager 70%, you got to tell him like 95%. He's gonna, what do you mean 70? You told me 90 last week. Yeah, it's 95.5. Yeah, that's kind of a danger of throwing kind of decimal points in estimating. So the network is reliable until things fail, until the router fails, until the disk fails, until somebody does something within the data center, right? It's until this, until that, and all of a sudden you've got a problem. So that's kind of the network. I think everybody gets the network. The next one is latency. So when you develop on a single machine, right? Anybody cares about latency? I don't care about latency. You develop, I don't think I've ever even thought about latency. I'm on a single machine, you just run as Java application, blah, 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 put a breakpoint and done. But latency is important. So if you're doing within the same process, it's what? We're talking about probably a third of a nanosecond. You go inner process, you talk about maybe a few nanoseconds, and you start going across LAN, maybe it's milliseconds, and you get into kind of WAN, and you're talking about 50, 80, 100 milliseconds. So we're not talking about, you go from a third of a nanosecond to 1 nanosecond. You're talking about a third of a nanosecond. You all of a sudden, when you do go all the way to production, and you've got a huge application, you go from a third of a nanosecond on your laptop within the same process to 100 milliseconds. That's magnitudes. That's not 10%. That's not 20%. You're talking about thousands, magnitudes of a difference. And it's most insidious when you use dependency injection, right? You've got just a very simple, got some controller getting injected, some repository, because God love repositories. And you kind of work as though it's in memory, right? A lot of junior developers, that I deal with, right? They get some dependency. All right, I get some repository dot, some method. All right, fantastic. My laptop, it's fantastic. It's just that little dot that's killing me. That dot, right? When you press that dot, I want like a little. The HR will probably have a little problem with me saying it, but I want like a little shock to the developer. Just a little bzzz, You press that dot, you go, what just happened? Like, who was this? Just think about it. What do I think about it? I get something injected to me, I'm just calling it, like, what do you want me to think about? Latency. Latency what? I'm on my laptop. What do you want me to think about? It's important. Which kind of, so it's like, all right, so you hibernate, whatever, ORM or not on ORM, whatever you want to use, it's, right, you've got kind of, all right, so latency is a problem, so I'm going to eager fetch. All right, I'm going to eager fetch, fantastic. Which kind of falls into the other fallacy. The bandwidth is infinite. So, the Moore's law? Everybody knows the Moore's law? Kind of like CPU, right? Like over the last so many years, every 18 months, every whatever so many months, it's doubling. Gee, I don't know, like my laptop, for God's sake, is like faster than the server that I used to run, 10 years ago or 5 years ago. Like, Jesus, what's going on? The memory, the memory is just like doubling, just getting so much cheaper. Bandwidth. You're at your house, has bandwidth really doubled every 18 months? Like, are you at like terabytes per second of download? Hell no. I'm calling Comcast, like, guys, like I'm at like 1.5. Help me out. You're telling me it's like 30 megs per second. Like I'm downloading a movie I shouldn't be downloading, but I'm at 1.1. Bandwidth is not doubling. And what do we, and a lot of times you ask the developers, it's like, I don't know how many you guys know from a data center perspective, the Ethernet. It's like, oh yeah, we've got our data center is 1 gigabit, 1 gigabit per second. Developers, gigabit. That's a lot. I'm not thinking about bandwidth. I should care about. I'm on my laptop. I'm coding. I don't have to think about gigabytes. What's a gig? So network people think in gigabits. We think of in terms of gigabyte or bytes, right? They think of bits. We think of bytes. So 1 gigabit is what in terms of bytes per second? 128. 128 megabytes per second. So you're like, oh, really? I just went from giga to 128? And you start talking to your network people, you go, yeah, but see with exponential backoffs and sliding windows, and it's really like 50, pure Ethernet. TCP, 40? Oh, you're doing serialization, you're doing this, it's like 30. And as developers, nobody thinks about that. I talk to developers, do you know what's your data center running at? I don't care, it's somebody else's problem, not my problem. Why do I got to think about it? Architects, data center, I just put it on somebody else's lap. Their problem. So you go from all of a sudden to 1 gigabit to 128 megabytes a second to maybe like 50, and with a bunch of other stuff and serialization and all this other stuff, and you go like 40 and 30. That's a significant, right? In your mind, at least in my mind, that's a big change. You go from giga all the way to like 30. And what happens if you have, it's like adding another car to a congested highway, right? The highway is already congested, right? And when we scale out, all right, we're going to scale out. That's putting more cars on an already congested highway that we don't think about it. Sometimes you've got, what's a good example? Like fraud detection and reporting. Fraud detection is, if I probably ask a lot of people, that's pretty important, right? Compared to, let's say, reporting. Some internal business user wants to do reporting, and we've got fraud detection. I'm going for the fraud detection. That's kind of probably more important to me. So what do you want to do with the bandwidth? Do you care? Well, no, I want to make sure that the fraud detection actually has a higher priority than some dude running in some office running some reporting on on the same pipe. So just got to think. So you're kind of in a bind. So you're telling me eager fetching, right? Latency is a problem. So I gotta get the data ahead of time. You're telling me bandwidth is a problem. So I don't know where to go. I don't know what to do. So the question is, there's not really a solution. A lot of times people look for silver bullets. There's no really silver bullet. It's more of a, right? You got to think about it. What's more important? How do you design your system? You can create virtual networks. A lot of developers kind of don't realize that, yes, on that one network, you can create a virtual network. You can't say that for fraud detection, I'm actually going to allocate more. For reporting, I'm going to actually allocate less. That's the type of stuff that kind of, wakes you up at 3 in the morning and somebody's calling you that something is down or something is slow. So a lot of times, instead of having one monolithic, humongous database, I don't know if anybody has that type of, right? It's like this huge Titanic. You're like, I'm trying to turn it. It's taking a while. Sometimes you want smaller things. Sometimes for one context, you want to eager fetch. For a different context, well, I want to maybe lazy load. It depends. Next one is topology. Topology doesn't change or won't change. So it's more of a physical topology that has to do with we've got a lot of time you can hard code an IP. I've had this is a true story. I was like, yeah, latency. We've got some problems here. Listen, I promise we're going to put these servers in the same rack. No latency, or little of it. That guy gets fired, promoted. Somebody else comes in. Rack? What is this rack? When I move things around. But no. I assumed my design was that the servers were on the same rack. Can't assume those things. Can't assume that things are, just the way you had a meeting with some data center dude and he told you, yeah, I promise you. Can't assume those things, right? You just gotta pretend someone's just gonna move things around. And sometimes, the best way, when you deploy, unplug things. Anybody actually unplugged? Like I've been in a lot of, I've mostly worked on the Fortune 500 companies, but you've got the, your QA, the staging, production, performance environment, but does anybody actually go to performance and says, I'm going to unplug this, I'm going to unplug that? Like Netflix got the, I don't know if people know, like the KS Monkey, they got the KS Gorilla and the Kong that literally just I'll do one server, I'll do a little network here, and then I'm just going to unplug the whole data center. That's difficult to do. You got to coordinate, right, with your ops people, the network people. Hey, listen, I want to do a test. I want to actually unplug. Like, what? You want me to unplug a data center? Are you crazy? I'm not unplugging a data center. No, I want you to unplug a data center. I want you to break that connection for me. I want to test. That's important. The other one is administrator knows what to do. That's that's very common. All right, like I said before. Oh yeah, I've got some dude over there. He'll take care of it. So it's not so much that he's going to get fired or anything. Sometimes he gets promoted. He gets a new position. But he knew what to change. Well, he got promoted. Somebody else comes in. And we've got, I've got this fantastic, I'm using Spring, and I've got a circuit breaker pattern for throttling, and because I don't want my system to get bogged down, so I'm going to throttle. This is actually a good pattern, but so you put a lot of stuff in the config, and whenever things change, we'll change the config. Does every developer actually know every single, not 70%, every single line in the config? Well, no, I know most of them. Oh, what do you mean you know most of them? Because the administrator is going to change it. Well, you ask the administrator, do you know every single line? No. It's all automated. We've automated all this stuff. But why do you keep telling me that the administrator is going to change it? That's just for us. That's just for our ease. We're gonna change things. So it's always a best practice. A best practice is always to make it configurable. But then over time, you go to some developer and you go, hey, do you mind if I do you know what this line does? I don't know. Should we just remove it? No, I wouldn't remove it. I don't if you remove it. So over 7 years, you look at this file and you're like, Jesus, all right, I'm going to leave it alone, right? And then you're on some project and you've got, I don't know, a bunch of things, and you're like, I don't know what any of it does. I got to look up the code. That's where we are. So, okay, we're kind of like, all right, who cares about who needs to look after your configuration? Everything you're moving to the config, who's actually looking at it? You got a plan? Developers know it. Is it documented? Is it not documented? If I'm a junior developer, I always go back to kind of me being a junior developer. And if I go on a project, do I know exactly what to do? And the other piece is kind of developers are high availability. High availability, man, that's not my domain, right? So if you've got, you ask the 5 nines, everybody knows the 5 nines, right? So it's the 2 nines is 87 hours downtime, 3 nines, 8.7, and so on, right? So if you do, how many have 4 nines? You got 4 nines? Awesome. That's the goal. Anybody know? Anybody think about it? Like how many do downtime, right? When you deploy, the question is always, right, like, yeah, we want to do continuous deployment. That's always good to put on your resume. I do continuous deployment. Oh yeah? Like what's your downtime? Like 5 minutes. So you continuously deploy and you're down for 5 minutes. So you're telling me you're continuously unavailable, right? You're continuously deploying, you're down for 5 minutes. Like, are you ever on? No, I'm confused. Well, no, at some point you gotta know. And the developers are usually like, we're gonna give it to somebody else to worry about it. And a lot of times you have to have, there was during the keynote yesterday, right, there was a fantastic thing, right? You've got, through the Cloud Foundry, you've got kind of 2 versions running, and you can flip one to the other. And that's the stuff we've got to think about. That was actually a great example that kind of fits into this, that, well, you got to think about it. The next one is kind of the system is atomic. How many have like a big bowl of mud type of application? Probably not something I want to, oh, we actually have 2 brave souls. You inherit it, because there's no way you could do it yourself. I would never create a big bowl of mud. It's that other guy that I inherited from. So I just want to talk about, because this is the stuff that I deal with kind of every day is, you know, you build an application and I fight so much not to get into that big bowl of mud. And how do you not create that big bowl of mud? Because you know you're going to create that big bowl of mud. And just some of the things that kind of get you into that big bowl of mud. Time, constrained by time, deadlines, things happening, right? I'm just going to do things faster. Lack of experience. Turnover, people leaving, people quitting, depending on the company. Because we have a fantastic company, people never leave. No. Skill, different skills, right? Complexity, sometimes the domain is so damn complex that you just use whatever you need to do just to get the job done. Change, things, you know, business all of a sudden, flip-flopping, I got to do this, I got to do that, change this to this. Oh no, we're in this domain now, we're got to do this, we're got to do something else. And then cost. And then cost is kind of the biggest thing is, right? Architecture costs money. Architects, ivory tower, let us know when you come down to join us. And we kind of use this, you know, we used pragmatism. This was a pragmatic decision to get to this job, right? A DBA told us you can't do this, so we created a column. This happened. We created a column with a delimited string where we can put stuff in because the DBA told us we can create some other table. That was a pragmatic decision, right? That was my choice. That was a pragmatic decision. And we kind of start out with, we're all happy in the beginning of a project. And, you know, before every fight, you know, the boxer is like, I'm happy. I'm going to win. Over time, you get knocked down. You're down. And what the hell just happened? Like 3 years went by, like, I'm down. Sometimes you want little pieces. So instead of one, remember that like 100 table database? Sometimes instead of that humongous monolithic code base, you want little things. Sometimes I just want to move slowly. Sometimes I just want to take that piece, like, this SQL file is fantastic. I actually want to try it, but I've got like 150 table. I can't go to my boss and say I got to go from Oracle. It's too much. Forget it. Sometimes you just want to move things along. Sometimes you just want to take a little piece and like, oh, for this little context, I can try to see if I can use this specific technology that I learned at a conference. It actually fits us really well. Right? It's very hard when you have these humongous, huge, right, databases, code bases. The other one is the system is finished. So we kind of started, so you've got, if you look at the y-axis, and the y-axis is kind of the effort, and then the time. So you kind of start out, all right, here's our date. We've got to hit that date. All right, here's when we're done. And all right, so this is when we're done. All right, so a lot of times the developers go, all right, I want to work on the greenfield stuff. I'm not maintaining the system. Right? But is there a difference? So a lot of times we kind of think that our product is actually done. But it's never done. It's ongoing. What's the difference between putting developers, right? You're adding features when you're doing greenfield development, and you're adding and modifying when you're doing maintenance. And a lot of times, right, the managers, the maintenance. Who are we going to put on the maintenance? The skilled person, or the guy who's like, we got hired from some college? We're going to put those guys that got hired from college, right? Do maintenance. But maintenance is the hardest part. That's an existing code base. You want to do the opposite. You want to put the skilled people. But the skilled people go, maintenance, that's legacy. I want to do some new stuff. I want to use Spring 4. I'm not doing Spring 1.1 from 1945. Huh?
Before the modern computer was even invented.
You got it. And what happens to all of us? How do we swear? Rewrite. I'm going to rewrite. That's how developers swear. They don't say, they don't use bad words, but we just say, this new feature, rewrite. Honestly, do you really think you're going to take this whole system, build it from scratch, add the new feature faster than just by adding that feature on the old legacy system? Legacy. No. Just want to work on some cool stuff. Right? I don't hear any developer that says, yeah, I want to use Spring 1.1. No. So it's a lot about, it's never about finished. It's a product, right? So kind of like Apple. If they had the iPhone, this is what the iPhone would look like now on the right, right? No, right? It's a product. It's a constantly evolving thing. You need kind of stability, and you got to sustain that product. Business logic should be centralized. It's kind of a fallacy. Like, what? It's a fallacy? Like, what do you mean it's a fallacy? Like, anybody not want to centralize? All right? You talk to developers, like, you want to centralize? No, I don't want to centralize. I want to do it all over the place. No, I want to centralize my logic. No, I don't want to centralize my logic. So let me give you an example. So you've got some entities, pretty clean. Looks fantastic. Bottom layer. You've got some more layers on top. All right? Yeah. I'm using the lower layers. That's where I'm centralizing the logic. Right? Can't argue with that. What happens when more layers get added? Hard to visualize kind of your code base over time. Because best practice has been kind of lodged in our minds for whatever, last 10 years, right? That you gotta have the business logic centralized. Can't spread it around. you start visualizing a system over time, this big ball of mud, this is what it looks like. Why? Because over the last 10 or 15 years, that's kind of where the developers have been, right? There was no source control 15, 20 years ago. All right, so we got to kind of centralize. It's very hard to do, right, to find some file that does this logic. But nowadays, Git, anything else you want to use, right? You can tag things. You want to find something, you can find it through the source control, right? But we're kind of used to this best practice of centralization. So I'm not saying that centralization is bad. Just saying you got to find what changes often, what doesn't change often, and kind of find the right balance. And sometimes, we're trying to kind of kill the two birds with one stone, and we create a dependency. So sometimes it doesn't pay off. The second part of the talk, I want to talk about kind of loose coupling, right? You talk to a lot of people. Is your system loosely coupled? Of course it's loosely coupled. Are you loosely coupled? I'm loosely coupled. Are you loosely coupled? I'm loosely coupled. What are you talking about? What's loosely coupled? Like, what's the actual definition of loosely coupled? We all talk about we want things loosely coupled. What's loosely coupled? Have we actually defined? Like, do we actually all right, loosely coupled means X, Y, and Z. Are you loosely coupled? Yes. No, it's just like, are you loosely coupled? Yeah, I wrote some code that's pretty loosely coupled. What do you mean? I don't know what I mean. What do you mean? So what is loosely coupled? What is loose coupled? Let me talk a little bit about it. So you've got afferent coupling, which is people use like Sonar and JDepend, and there's a bunch of tools. It's the things that depend on you. So if you write classes, those are the classes that depend on you. That's CA. Afferent coupling is who you depend on. That's kind of like outgoing coupling. So if you look at this diagram, this chart a little bit, so you've got the higher you go, so on the y-axis, that's the things that depend, so CA is who depends on you, right? So who depends on you? The higher you go, who depends on you? On the x-axis, to the right, is who you depend on. So number one, what would you say this would be? We're at a spring conference. What would that be from a coupling perspective, right? More like a framework, right? Spring is a framework, right? So number two, so if you go back at CA, who depends on you, right? So framework, if you are Spring, if you are the Spring framework, right? A lot of people depend on you to do a lot of stuff. From a keynote yesterday, there's a lot of magic happening. A lot of things depend on you. Number two, kind of DTOs, right? Some objects that, right? Number three, who do you depend on when you build an application? Just some ideas. Throw some out, if anybody's still following. Okay. Okay, so like UI could be that, right? I depend on some UI. That's a form of coupling. Platform coupling, you've got, right? You're doing very Java-specific things. You're doing node-specific. You're doing, so ADP has a lot of PHP, Java, .NET. If you're doing very specific technology, right? That's platform coupling. That's another form of coupling. Let me skip that. Spatial coupling. That's another form of coupling. Do you depend on when you connect to something? Do you depend on failover, clustering, right? That's another form of coupling. And when things are down, right? What do you have? Do you have a load balancer that kind of fails you over? That's another form of coupling. Temporal coupling. If you have a service talking to another service, and so for example, if you need to get data access or right, some data from another service, that's another form of coupling. So what you want is kind of inverted data flow between two parties. So instead of requesting things, I need something from some service, you might want to do a pub/sub. So pub/sub is great when you do a lot of reads, but the problem is you might be operating on some stale data, right? Somebody published you an event, you store it locally, and you use it to make some business decision, right? You could be operating on stale data. Could there be, so when you use a web service, a REST call, anything within your system, is there a possibility that you could be using stale data when you use a REST service? Well, yeah, right? By the time you get the data, serialization, blah, 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 you get it back, somebody could have updated the data. You talk to the business, and the business tells you, oh no, we need consistency, right? So pub/sub kind of gives you, what I like about pub/sub and messaging in general is that it kind of, it makes you think from a perspective of when you talk to a business, you go, hey, if I get an event over here and I capture that event and I store that data locally, and the business kind of tells you, no, you're working on stale data. And I go, oh, okay. So sometimes you kind of fall back and say, all right, I'm going to do RPC, right? Because I'm going to get in trouble, but a web service, a REST call, right? That's just another way of doing RPC. You're calling something over some protocol remotely, which could, in the meantime, while you call, the data could have changed. But the business is telling you, no, I want 100% consistency. They also want 100% availability, but they still tell you, all right, I want 100% consistency. So what is the business telling you? In essence, what are they telling you? You want some data from somebody else? Pub/sub, not so much. HTTP call, still a problem. What are they telling you? Those two things can't actually be two things. They have to be one thing. The data has to be consistent. Those two services, they cannot be separate. Pub/sub will not help you because the business told you that you're working on stale data. But we all, at least every project that I've been on, right? Web service, HTTP call, right? That's the next thing. All right, we're just going to do an HTTP call. It's so simple. But it also gives you inconsistency. So what does loose coupling mean? You've got 5 dimensions. You've got platform coupling, spatial coupling, efferent, temporal coupling. What is loose couple? Well, it depends, right? If I want, for example, we're choosing RabbitMQ, which is a fantastic queuing technology, messaging. So we kind of decided, all right, so RabbitMQ actually gives us less of a platform coupling, right? It gives us less of a temporal coupling and less of a platform coupling. Why? Because it's based on AMQP. Huge companies, again, I'm not talking about startups. Startups are different. Sometimes in startups, you want to figure out what your actual domain is, do it the quick and dirty way. You don't want to apply any of these principles. You just figure out what makes you the most money and then kind of redesign, just like Instagram and a lot of companies, right? Just do it the fast way and then figure out the best way to create architecture. But for us, we know what the business we're in. We know what makes us money. So internally, we're saying, well, Rabbit actually, right, gives us kind of, right, we're dependent on the platform. We're dependent on MQP, gives us less temporal. So that's a decision, right? If you use ActiveMQ, anybody use ActiveMQ? It's a choice. So the last part I want to talk about is kind of different principles. Just right, you're building a project, and what do? You've got, I mean, you go to different talks and you've got people pumping service-oriented architecture, and all right, you've got to do domain-driven design here, and event-driven architecture is great, and test-driven development is fantastic, and behavior-driven design, it's awesome. But sometimes you don't want to just apply cookie-cutter approaches, right? The idea is not to take something that's just, right, you're like, oh, this is awesome. I'm just going to start applying it everywhere. When you build a house, you've got plumbing, you've got electricians coming, electricity, you've got every piece has its own specification. You don't just say, all right, I'm going to make this whole thing, some project that I'm working in, service-oriented. I'm going to make it domain-driven, I'm going to use DDD. I'm going to use this. No, for this piece, it makes sense to use a domain-driven design. For some other piece, it may not. But people don't like this model, right? I talked to a lot of guys. A lot of people want cookie-cutter approaches, right? Just give me some reference architecture I can download, I can get good at, I can put on my resume, I can be fantastic at, I can go back to my team. I'm the star, I'm the superstar, because I know it so well, I just want to start applying it everywhere. That's difficult, right? It's much difficult to tell people to, no, for this context, actually DDD is not great, or service-oriented is not, by the way, SOA is not really our architecture, it's just a style. That's just a style. People think it's just architecture for the whole company, for the whole project, for the whole system. No. But people want, at least my experience is people want cookie-cutter approaches. And that's kind of been my most difficult aspect in kind of correcting that. It's not a cookie, it's an approach within one aspect, but not the whole aspect. We like kind of a flavor of day. Right? We're doing SOA, all right, everything is a web service. Kind of like when Amazon wrote a letter in like 2003 when, who's the CEO? Jeff Bezos, right? So when he like, all right, we want to be service-oriented. But that doesn't mean web services, right? To a lot of people, service-oriented architecture style is like, all right, we're going to make everything web service. That doesn't mean web service. Actually, SOA was coined in 1996. There was no web services. Web services came about when you've got IBM and all these huge companies saying, all right, we want to interoperate with each other. What do we do? All right, we're going to create these WS star standards and addressing and atomic transaction and all this stuff, and we're going to interoperate and we're going to make it, right? And somebody looks at it, oh, web services, right? Services equals web services. Well, no, services does not mean web services. Web services are very specific. Services just mean something that contains your business logic, something that aligns with your business capability. And we've got kind of over time, we've got monolithic procedural code now done over REST. REST is fantastic. All these sessions on REST, my God, got to do REST. But it's the same code. Now we're just basically saying, all right, so now we're just going to do it over HTTP. That bad code that we've all kind of been designing, we're going to make it really fly over HTTP now, because that's going to make it faster. On my laptop, it was fantastic, but over HTTP, it's going to make it even faster. No. And this is what web services kind of, if anybody ever played Minesweeper, that's what I got in my mind. Right? And somebody says a web service or anything, that's the image that comes to my mind. That's right, like you press, anybody played Minesweeper? Yeah? Right? You press, an incorrect tile, bam, the whole thing is blows up. Right? You've got services calling other services, right? Something goes down, you're down. Martin Fowler kind of said the first rule of distributed computing, don't distribute. Like, what? No, don't distribute. If you don't have to distribute, don't distribute. That'll be your fastest way. Right? I talked to, so we use SQL Fire for a lot of things in GemFire, and right, so they've kind of got a similar strategy of co-locating data that if you need data that you use often, you want to have it in one box. You don't want to do distributed joins all over the place. You want to have it local. That is the fastest way to get things. But if I ask you, like if I ask 100 people in the room for a specific problem, right? Just any problem. Give me a solution. How many answers will I get? 200. That's true. I was going to say 100, but like every person is going to have like at least 2. I may have like 5, but yeah, that's true, right? You're not going to get one solution. But how come you still use the same, right? You go from company to company, project to project. Do you use the same solution? Yep, Oracle, Spring, blah, blah, blah. That's the way we're going to do it. No. Every solution requires a different, right? Sometimes, like for this context, actually, it looks like GemFire or SQL Fire may be the best solution, right? Whatever, it doesn't have to be Oracle Coherence could be the best solution. But sometimes you're like, you pick the technology. Like I started at ADP, and the first thing I was told was like, here are the technology. Like, oh, I thought I was the architect, and I guess I'm not architecting anything because you've already picked things up for me. Like, why do you even need me? And that's all right. The technology is chosen for you, and what you want is distill the problem, make this whole complex domain, separate into services that kind of fit, and for every service, you want to figure out what's the best technology. And that's very hard to do. Some guys inherit a big system, technology is chosen. Very hard to do. What you want is to be nimble. You don't want to be brittle where you have one huge thing and you're like, oh, this GemFire and SQL Fire is so freaking fantastic. I want to use it, but I can't. It's hard. You want things in little pieces so you can move faster. I actually like Martin Fowler's definition of what an architecture is. Things I wish I knew 6 months ago at the beginning of the project, right? That's what my architecture should have been. Right? It's very hard to come up with an architecture. Like over like 2 years, you go, oh, yeah, that's what my architecture should have been. Like if I did this and I modified this and I used this technology, that's what it should have been. So if you look at this picture, so if you look at kind of, right, you're driving a car, using a keyboard, using a remote, what are we kind of saying? I don't have access to the internals of the engine, right? I'm using a keyboard, I'm typing on a laptop, I'm using a computer. Like I don't know what's going on inside. A lot of people do, but I don't know what's going on inside. I'm using an interface. I'm using a remote. I'm just kind of operating a TV. So what are we saying? What's good, right? Over time, what are we saying? Encapsulation. Abstraction, encapsulation. It's good, right? We've kind of, over many years, we've been kind of fighting this battle of composition or inheritance. Anybody worked on like these humongous code bases? I know I've said this before, but right, these humongous code bases with these huge inheritance trees? Anybody? Yeah, it seems like the legacy guys. He's pouring his hair out. We've kind of said that composition is good. Encapsulation is good. Inheritance, although sometimes required, right? got to know what to do. With large, humongous code bases, when you start out small, inheritance is like, it's so simple. Just implement this interface. Over time, it's huge. Very hard to evolve a system. So we basically said we want composition over inheritance, right? I don't want anybody reaching out to my data. I'm going to encapsulate my data. I don't want you touching my data. So if we're saying services should be autonomous and self-governing, this is my only slide with bullet points, or one of the two, should have explicit boundaries. We're basically saying we want encapsulation. I'm going to get into kind of how we do things at ADP in a second. With web services, so you have a service calling another service, calling another service. You're saying, would you say that that's service number 4? Would you say that that's autonomous, highly encapsulated? Given that, let's say, service number 5 takes longer to get you the data back, you're dependent on somebody else. Are you highly autonomous? Are you encapsulated? Well, that doesn't sound very autonomous. That's not very encapsulated. It isn't. It's not encapsulated. But we all have this problem of just, right, service calls another service, and all of a sudden you don't know what the hell is going on. If you look at the iTunes, just as a page, you've got pricing, you've got different specifications for a laptop, you've got images and all that stuff. If you look at it from a kind of business perspective, pricing and reviews are probably different concepts, right? You've got pricing, you've got reviews, they're different concepts. You probably want similar decomposition from a software perspective. And if I'm responsible for a piece of data, if I'm responsible for pricing, think of any domain that you're in. If you think about that one aspect, whether it's pricing, whatever it may be. I'm just using pricing as an example, right? What does that responsibility really mean? Like, I'm responsible for that data. We're saying I want encapsulation and I want alignment. With web services, is the data encapsulated? Well, like I'm a web service. I'm providing data to somebody else. I don't know what somebody else is going to do with that data. Do you know? Well, what do you mean? They're calling a web service. They're going to display it. I don't know how to. I'm on the hook. If you're saying from an object-oriented perspective that encapsulation is good, you've completely disregarded that aspect, right? You apply it in the code from a Java perspective, right? But then all of a sudden you create a web service that completely abandons that perspective. You've just said that encapsulation is good, but now you're giving access to your data. They can do whatever the hell they want to do with that data. Right? I don't want to hand off the data to anybody else. If pricing has to be in front office and the back office, if I have to do reporting, I got to be everywhere, right? If I'm encapsulated, so if you take your object-oriented from a object orientation, if you're saying encapsulation is good, and maybe there's probably some people who say, I don't know, encapsulation is bad, but the majority of us will say encapsulation is good, right? I got to be everywhere. What does everywhere mean? So if you look at there's this thing called 4+1 architectural views. And one of the things it talks about is your logical, we kind of say like that, we kind of think this way, that your logical and physical are the same. I've got pricing, people want pricing. I'm going to create a separate service that gets people pricing, right? Logical means physical, right? I'm going to create a service that's going to be installed somewhere else, some scaled the way it needs to be scaled and load balance and blah, 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 that people need to get pricing, right? But that's physical. What is logical? Well, logical could be, pricing could be anywhere. What does anywhere mean? Well, anywhere. Any application that needs pricing, I'll provide it for you. Like, what do you mean you're going to provide it for me? Well, right, I'm going to, what application are you running to? I'm using blah, 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 blah. All right, I'll get you a component that will display pricing. That's not how most applications are done, right? And most applications are, you've got somebody needs pricing, you call a web service, you call whatever, 0MQ because you want performance, and you don't care about persistence. I'm going to call that. I'm going to display it myself. I'm going to display it myself. But no, we just said the encapsulation is great. You just abandon. That's what I'm trying to get to. That people abandon those principles that we found out that are great principles. Well, apply them. Don't just apply them in one aspect. Try to apply them everywhere. What does that mean? Well, I got to get pricing to you as a component. I'm going to plug into your application, your invoices, your back office, your front office. Any application that you have, I'll be in there. You know, in the beginning, that screwed with my mind. Like, that's a PHP application. That's a Ruby application. You've got to, at the end of the day, if you believe in encapsulation, and if you think that that's a great thing, then apply it. If those are the principles that you found out over time had great impact over large code bases, then that should apply. And that's where I'm at. That code, right? I'm wearing an AngularJS shirt because we use AngularJS. We apply it, right? We provide a component to different applications. And if it's all of a sudden, if it's a PHP application, we'll write a PHP component that will be plugged into your app that will get your pricing. There's a lot of intricacies of how that's actually done. Wish I had a second talk where I can actually go into demo and from how it actually gets composed. But you're kind of in this aspect of you've got this logical and physical leg, right? We all think of, right, logical as physical. I don't think any of us, at least the projects that I've been in, anybody actually thought about that logical is actually separate from physical. How you deploy it is different. Logically, I'm responsible for pricing. Physically, I could be deployed in multiple applications, and that screws with people's minds because they automatically say logical equals physical. And it's kind of like saying, all right, I've got my logical and physical lag. Right? I'm going to go scale now. Right? Look at me scale. Oh, I'm scaling. Oh, I'm going to go to the cloud now, get more legs. Oh, I'm going to go even faster. No, not going to go faster. So when you look at this page, that's not the same service. It does not mean it's the same controller that gets you the data. You have these widgets. So in the background, right, you've got a bunch of stuff. From a consumer perspective, well, it's a page. I don't care how it's composed. I don't care what it does, how it's done. It's a page. But if you want to make things encapsulated, I got to be everywhere. If I'm a pricing service and you're in some app, I'm not going to give you a web service. What? No. Tell me how you want things displayed. I'm in charge of my own data. That principle has stayed, right? That's what I've learned in the last 10 years. Encapsulation is good. That's how I can grow large code bases. If you want to grow large applications, I'm going to be there. No, just give me a web service. Just give me an endpoint. I can call some JSON, parse some data, display it. No, can't do that. I'm on the hook. Can't do that for you. I'm going to be there. I'm going to get you a component. I'm going to give you a Java. I'm going to give you an AngularJS directive, whatever. Again, doesn't have to be AngularJS. Any could be Amber, right? AngularJS has great things of like directives, and I can be there. I can provide callbacks to get you the data, but I own the data. I'm on the hook. Now I'm going to give you a web service, and that's where I'm at, kind of with being at large companies is the first thing that I kind of fight with people, including high-level people, is that, right? Just give me a web service. I'm sorry, I don't have a web service. No, just create one. No, I'm sorry, I don't have that on my plan. Well, how are you going to get me pricing? I'm going to be there. Well, I'm sorry, you're on a Ruby application? All right, I'll get you the Ruby. We have software engineers. We don't have Spring developers. We don't have Java developers. We have software engineers. If you have different applications, we'll be there for you. Obviously, if you're in a company that's just Spring, that's a lot easier. But if you're in a company that has a lot like we are, I'm going to be there. And that's kind of a different mindset for people. So a couple. Yeah.
Sorry, I'm trying to follow the
Yep.
logic there.
Yep.
Web services being, it sounds like you're not very pro web service, but so if you are authorizing a request for something like that, what's wrong? Why are you not encapsulating a web service if you're only exposing the price, not the update of the price or the new price? How is that not also encapsulation?
Sure. So how are you not encapsulating a web service? When you give a web service, like I said before, do you know what they're going to do with it?
It's a price.
Sure. But do you know what they're going to do with it? Can you guarantee me that they're going to do right by that pricing? A lot of times it's like, well, what do you mean? I give a pricing, they're just going to use the pricing, right? Like, what are they going to do? Are they going to modify it? Well, no, there's conversions and there's currencies. Like, do I got to provide more methods and they got to do conversions? And if I have different applications that want to do currency, they have to update the currency as well? Because I just give them the pricing. But they all of a sudden I want to do from US dollar to, right? What do I got to do? I got to create another method, and do I trust them? Why do you not do that same thing when you code?
In that case, do you do that then? So you are advocating that you should.
I provide a component.
You provide that translation?
Yep.
You provide for example, the internationalization
Yep.
of the price?
Yep.
Where do you draw the line? I mean, when do you stop?
You draw the line at the very highest level. What's the highest level?
All the way up to the functional level?
All the way up. I don't know what you mean by functional, all the way to the functional.
For example, some other business now has a requirement that I'm in X currency, you know, and you didn't originally plan for that. Now you have a requirement to support this new conversion, right? You didn't have that before. Now you are worried about that rather than just providing data. I'm just trying to understand.
It's a matter of, in my mind, it's always a matter of any coding that you do, right? It's the same type of stuff. If somebody has access to my data, I don't know what they're going to do with it. Here, I'm basically saying I will be there everywhere. It's a different mindset, right? Not saying, right, you got to always evaluate pros and cons, just like with any design approach. My approach is always, I want to be where the data is at. I don't want to rely on providing a service, because once I provide a service, then somebody else could call my service and somebody else calls them to get something else. And over time, you don't know who's calling whom. Yes, you can use discovery, and there's different approaches. I'm saying I don't need that complexity. If you need my data, I'll provide it to you.
Inevitably, you'll run into situations, for example, batches, right, where you have to provide data to third parties or to other applications.
Yep, which is a different context, right? So One approach is UI composition, which is what it feels like I'm advocating. You have server-side composition, you have data-side composition, right? And you have batch processing. So it depends on what the context you're in. So if you need to provide, for example, like Twitter, right? They make a lot of money just by feeding the data to other companies that they can analyze. And if that's what your core domain is, then that's what you do. But from building an application, from making things composable, that's one aspect. From providing data, that's a completely different context, and you would solve it in a very specific way by using whatever prop, right? If I got to provide some data to somebody else, I can plug into some ETL job, right, that can provide data to what they need as well, right? I can be anywhere. That's what I'm trying to kind of get into, is I could be anywhere. If there's a bad shop, I'll be in your bad shop. Let's talk about it. Let's figure out how I can plug in, but I'll plug in, right?
Do you have other teams actually putting components into your code base? Let's
Yeah.
say this other team has a bandwidth. I mean, the work needs to be done anyway. So are you talking with other team will
Yes.
import into your code base and you will own this thing?
Yep.
Basically advocating that the authoritative source of the data is you're controlling it. You are the authoritative source.
I'm the authoritative source. Yep.
So there's one other question about
Yep.
manageability, right? So if you have number of consumers and they are on varying technologies, each one of them is doing upgrades at different points of time, and your component may need to be upgraded. So you actually have software developers plugged into all of those third parties.
One more time. Repeat the third parties.
So there are consumers. Let's not use the word third party, but consumers of your component, right? And those consumers may be on different versions of software, and they would go through their own upgrade cycles, right? So when they go through their own upgrade cycles, they will. The component that you have developed or provided also needs to be upgraded.
Sure.
So then there's a manageability issue, right? Like how many
Yep.
versions of your component.
But that's a different issue now. You're talking about from a deployment perspective now, right? So the question is, if I have to upgrade something, and if I'm everywhere, I gotta be deployed in 5 different systems now, or 10, 40, 50, right? Whereas a web service, I just do it in one place. But that's a different issue. That's a deployment issue and a management issue, which a lot of people start combining into, right? If you automate things, then you automate it from a separate perspective, right? For whether it's Puppet or anything else, but that's a different issue. Architecturally, right? If you're in charge of the data, you're in charge of the data. If you want to deploy it to 20 different systems, that's not right? As long as you automate it, as long as you manage it properly, then it's right. Doesn't matter whether you deploy it once or 50 times.
Sure, but deployment
It puts more complexity on a different aspect of the domain, but yes.
Do you have any examples of how you've applied this and what it looked like?
I do, but I would run over at least by 3 hours. So I'm hoping to, at some point, to get a different session where I can kind of go into UI composition and AngularJS and kind of go through an application where different components plug in and how IDs get interchanged with different components. All I can say is in the last 5 years, it's been really difficult, right? These principles are very difficult, but things like Backbone, things like Amber, things like AngularJS make it a lot simpler. That it has dropped down significantly from a complexity perspective. So if you use client-side frameworks, any kind of MVC framework, and I was talking to a few people, some of them use it, it brings the magnitude of complexity down tremendously in the last year or two, just from things like Angular, like I said, like AngularJS and Amber and Dart. And
We're doing some UI composition currently, and so I get that. It's the
Yeah, that's very similar to that. So when you deploy, so instead of deploying, it's like instead of deploying a specific endpoint, you deploy, so instead of, in this case, you deploy a jar with something that wraps around it, right? But remember what I talked about before, right? When you use that jar and you just, right, it's just like something dot something, right? There's things that you got to think about what that does from a latency and the bandwidth, right? Reliability perspective. Here, right, everything is at the highest level. I'm on the hook. If something is down, you can point a finger at me. I'm in charge of my data. I will be, right, you can point a finger any way you want it, but I'm in charge, right? So we can talk about, there's a lot of questions. All I can say is in the very beginning, I've had thousands of different questions. It's very hard to cover in an hour and a half. I just wanted to kind of provide at least context or a different way for people to think. Whether some people agree or not agree, that's always up to the people, but it's always good to get a different perspective on things. It took a while to get to that level. All I can say that it's been, from a organizational perspective and a team structure perspective, it's been very helpful. And I'll cover a little bit of, I've got 10 minutes, but anyways, if anybody wants, anybody has very, very specific questions on how we do UI compositions and what happens, please come and talk to me. I'll be happy to get into details. It's just, it's a lot of material in an hour and a half, and I had to cut down. My original was like over 2.5 hours, so I had to cut down a lot of stuff. So I hope that at least from a perspective, from a different angle, you get a little sense of how you can do applications slightly a little bit different than what people are used to. But again, come to me. I just want to cover a couple more things, and we can have lunch. So I'll skip this. There's a there's a law that kind of explains of how we get into kind of problematic way of building applications. So you kind of have this, so Conway's law, just to get it off the chest, is basically saying that your team structure, how you have your team structure, trumps any architecture that you have. I've talked about some different architectural styles that maybe a lot of people are used to. All I can say is, if you take a high-level view, Conway's law basically says that your team structure will override any architecture that you have. That fantastic architecture that somebody came up with, myself, somebody else, whatever it is, different one, will get trumped by the team structure. If you have a team that's client-server DB, and you're saying, I want to do SOA, and I want to do this, and all right, you server guys, you do SOA, and then DBA, you guys do whatever, client side, you do whatever, right? What is your architecture going to look like? Client-server database. Agile? Yeah, we're doing Scrum, and we're awesome, but we have, you have product owners that are here, and you've got developers over here, you've got testers over here, and you got ops people over here. You product owners, you get your, you iterate, give it to the developers, they iterate, you give it to the testers, right? That's going to trump any type of agile methodology. If that's what your team structure is, anything that I talked about here is meaningless if you don't have the proper team structure. You come up with what your architecture should be, how you want it to be, whether you believe in what I'm saying or not, however you want to do it. Then put the team on it. Don't have the team before the architect, because the team structure will trump everything. Just think about anybody I talked to, there was not a single person, probably going to get somebody raise their hand that I'm wrong, not a single person that I've talked to, right, that didn't say, yeah, my team structure and my architecture, it is kind of similar. I got client server DB, I've got the, yeah, that's what my architecture looks like. That's what the problem with the team is. Create what you want to do. Tell your enterprise architect, your boss, your C-level person, no, we're going to create the way we want it to create, figure out that first, then we're going to staff it. Because if you're going to staff it first, if you're going to have, yeah, we have this service over here, common service over here, yeah, we're going to staff these people, guess what you're going to have? Yes, I'm not a fan of web services, that's probably obvious, but right, you will have those services, right? That's why you have a team that's in charge of that web service, any service, whether it's over HTTP or any type of service, right? You've staffed it that way. That's what your architecture is going to look like. That's the key point. Anything that I talked about, just kind of, right, you can dump anything I said, but that is the most powerful thing to me. And when I got hired, the first thing was, right, I had teams, I've had kind of technologies, and I kind of had to say, all right, thank you, appreciate it, but let me be for a second. Let me just figure things out. Let me see what the boundaries are, what the services are, how we're going to connect things. Then let me see how we can structure the teams. Yes, Scrum is fantastic. We use Scrum a lot, but let me figure out what the pieces are. Let's staff the people later. Because if you staff the people first for some service, that service will become a web service. And then you're going to have a team staffed for that service, and that's what your architecture is going to look like. So it's very kind of difficult. Sometimes you got to have a few battles, but that's kind of the most important thing out of this talk. That team effect is huge. It's not about Spring sometimes. It's not about whether you use RabbitMQ or SQL Fire or Oracle or any other technology. It's the team effect. It will trump anything. It will trump any architecture that you have if you have the team first. And if you can't shuffle things around. So architecture is as much of a people component as a software component. And if you're in a company that kind of doesn't, in this kind of space where, all right, I'm going to put this here, and you know things are going to fail, right? You're like, oh, I feel like, we don't know where, we don't know where we're going, and there's a great kind of sense of freedom. Oh, yeah, we've been doing BDD and DDD and blah, blah, blah. Do some RDD. Do some resume-driven development, right? Oh, I haven't used Scala. I'm being sarcastic, but I haven't used Scala. Oh, I'm going to use Scala on this project. You know the project is going to fail at some point, right? Long term, that whole rewrite, it's going to happen. You might as well enjoy yourself. That's all I can say, right? And you're like, I can see the future. Right? I'm not going to tell you, but I can see the future. Yeah, we should be using Scala over here. We should be using this over here. And Grails is fantastic. And yeah, right? Work on your resume in that case, because you know it's going to fail at some point. You know somebody's going to be screaming rewrite at some point. So if you want to invest in knowledge that will have a kind of very long shelf life, look at the principles that kind of held time, that kind of worked over the past 10, 15 years, right? If you believe in encapsulation, use it. Don't jump from one fad to another, one version to another. That's meaningless, right? Use the principles that you think, hopefully I build a good case, if not, use the principles that you believe in that stood over time, that kind of helped you, that you can apply later. Don't jump from one technology over to a different technology just to, unless you know the project is going to fail, then you might as well. Thank you very much. I'm sure some people have questions, and my name is Jeffery Sologov, and that's kind of where you can follow me. Much appreciated.